2.8, we're going to talk a little bit about solving absolute value. And what I want you to kind of have in your mind, especially as we get started with this, is why, whenever we tackle an absolute value equation, why is it that we solve two equations or two inequalities? For any time we do it, we're always working with two. Okay? So that's something you're going to keep in mind. I want you to be thinking about that. When we talk about situations that have two inequalities, it's either going to be a conjunction or a disjunction. And when we're talking about conjunction, we're looking for the word and. Okay? What this means is you might have something that looks like this. X is less than 7 and x is greater than 5. We don't often write conjunctions like this, but what we often do more so is write it like this, where x has to be between 5 and 7. X less than 7, that matches up right here. This here says x is greater than 5, which lines up with that part. That's why we can put them together and write it in that way, in that kind of a compound inequality sandwich type thing. Okay? When we're working with conjunctions, in order to be true, or in order to work, a point must satisfy both inequalities. So in this case, yes, 10 is greater than 5, but 10 is not greater than 7. It has to satisfy both. Okay? An example of a great number that would work here is 6, 5.5, 5.1, 6.9. Okay? Because it has to fit in this inequality sandwich, in this conjunction. Then we have disjunctions. Disjunctions use the word or. X is greater than 7 or x is less than 5. Okay? We can't put these together because all the numbers bigger than 7, none of them are smaller than 5. These two don't fit together. They don't overlap in any way. Okay? When we do these, a point must satisfy one of the inequalities. A lot more answer choices then. Here 10 works. 10 is greater than 7. It doesn't have to be less than 5. It's an or. It doesn't have to do both. It has to do one or the other, but it definitely does not need to do both. One way we can kind of think about this is in terms of a graph, right? 5, 6, 7, 8. Okay? 5, 7, and so on. When we say that x is going to be less than 7, that's an open circle and all of these points. And when we say x has to be greater than 5, that's an open circle in all of these points. Okay? So not anything real strange, but open circle in all these points. Okay? And what happens is we have the and that means it has to satisfy both. Well, the only points that satisfy both, come on. The other things that satisfy both are this circle over to that one. And they look open right here, or they look closed. We all know these are supposed to be open circles. Okay, between 5 and 7. And that's how we write that sandwich. On the other side, we got our 5, 6, 7, 8. 5 and 7 are the two key ones. X is greater than 7. Great. That's all these points. X is less than 5. Great. That's all these points. Any one of those points that is matched up with red works as a solution. Okay? So we got that word and, where we kind of make that inequality sandwich, and we have the word or, where we're disjoined. We're not together at all. They are separate. Two separate inequalities that have no overlap, nothing exciting happening. Okay? We need these for when we do absolute value. Okay? We need these for when we do absolute value. Here's why. Okay? Absolute value, we all know, is the distance from 0. A number's distance from 0. However, we can be that distance to the right, which is the positive side, or to the left. And so we're going to look at a couple examples. When we have the equal sign for absolute value, when the absolute value of x equals 3, that means we need to be 3 units from 0. If we go 3 units to the right of 0, we're at positive 3. So x right here is positive 3. The absolute value of positive 3 is 3. This is a solution. However, we also can go 3 units to the left of 0. 1, 2, 3. Well, now we're over here when x is negative 3. But the absolute value of negative 3 is positive 3 because that's what absolute value does. It turns things positive, right? We may want to add that to our definition because that's how most of you are familiar with it. It turns a number positive. A little math jail, when it gets let out, it turns positive. I don't know if you've heard that or not. But that's part of why we have 2 answers. Because negative 3, when you do the absolute value, it is 3. Or at a positive 3, it is 3. Okay? When we work with less than or greater than, that's when it gets a little bit more complicated. Okay? But let's look at these pictures, because these are awesome, awesome examples here for you. Still working with an idea of 3. In the first one, x, the absolute value of x is less than 3. That means we need to be less than 3 units away from 0. Okay? For example, this 2 is 2 units from 0. Negative 2.5 is 2.5 units from 0. Okay? We want to be closer into 0. And whenever we see less than, we want to think of the word and. This would be a conjunction. Less than. Okay? What we're saying here is that x has to be less than 3 or x has to be greater than negative 3. We can split this up. X has to be less than 3, right? 2, 2.5, 1, 1.5. All those numbers are less than 3 away. Okay, that's a funny looking 3 this one. 3. Then, the other way to think about it is all the numbers that would be bigger than negative 3. Greater than negative 3. And when we put that together, we get that inequality sandwich that we've talked about. And that's an and situation. Less than is an and situation. So greater is an or situation. If the absolute value of x has to be greater than 3, then what we're thinking about is, okay, I want all the numbers that are more than 3 units away from 0. I want 100 billion, I want 10, I want 5, I want 15, whatever. I want ones that are more than 3 units from 0. More than 3. Well, if that's anything over here, x is greater than 3. Or, I want all the units that are more than 3 to the left from 0. And that's how the ones x is less than negative 3. Okay? Because that's where we get our or situation. That's where we get our or situation. Okay? You can help yourself think about it by thinking about that greater and less than. Greater are disjunctions. They use the word or. Less than are conjunctions. They use the word and. Okay? Here's kind of the rule of thumb. When the absolute value of x equals a number, the way we go about solving that is either x equals the number or x equals the opposite of the number. Okay? No and, no or, just 2 perfect little answers. When x is less than a number, I'm using a for a number. Here's what that means. That means that x could be less than the number. And it also means, because it's less than, it also means that x could be greater than that negative number. When we put this together, we're looking at something like this. Okay? Because that's how and works. And allows us to put the 2 together. Okay? Or does not allow us to do that. So that's why in this third one, when we have absolute values greater, then x could be greater than a, the number, or x could be less than negative a. Okay? So that's where the idea of 2 sentences comes in. Look at, 1, 2. Okay? I don't know why the stuff on the left moved. But every time you're looking at this, here's 1, 2. 1, 2. They just make a compound sentence. 1, 2. Because we have to live on the right side of 0 and we have to live on the left side of 0. Okay, so we're going to take a quick look at how to solve some of these. Okay, so we have some steps we follow for solving. Unfortunately, it doesn't really change whether it's less than, greater than, or equal to. First thing you have to do is you have to get the absolute value by itself on one side. Okay, so right here, the first thing we're going to do is we're going to add 8 to both sides. The reason we do that is we can't split up an absolute value until it's totally by itself. Okay, so once it's the absolute value of 6x equals 30, then we can do the split up. Okay, and right here, we're looking at the rule for equal to right here. When it's equal to, 6x can either equal positive 30 or 6x can equal negative 30. It's either this 6x has a distance away of 30. It's either 30 to the right or 30 to the left. Okay? And then we just keep solving. Solve the two sides. Okay? So I'm going to solve the first side. I don't know why I'm showing you how this works. You guys are excellent solvers. But in the meantime, x is 5 or x is negative 5. Okay? Those are my two solutions. Then it says graph the result. Now, that only happens in inequalities. That only happens in inequalities. On a regular equation with equal signs, which we love, we're fine. We're done. Either x is 5 or x is negative 5. Okay? Let's look at another one. Got 3 to show you. Okay? In this next one, we can already see that it's less than. Less than. So we know we have to use the word and. But let's take it from the top. Get the absolute value by itself on one side. You bet. Checked off there, Bisto. We're pumped. Don't even have any work to do with that one. Write two sentences following the rule for that symbol. This is less than. So we're living in the and portion of our absolute value excitingness. So that means that x minus 5 could be less than positive 4, and it could be greater than or equal to negative 4. Okay? Now, when you notice, if you notice as we're writing that, the symbol stays the same. Look at this. That matches up perfectly. When the direction of the symbol flips, the sign on the number flips. Because that's when we're talking about living on the other side of the equal sign. So things are different over there. When we write the two sentences, we drop the absolute value. Okay? Finish solving. Plus 5. You bet, Miss Bisto. Just going to keep adding 5. Yep. There it is. 5 added all the way around. X is less than or equal to 9. And, bring that and down with you, x is greater than or equal to 1. Beautiful answer. Fantastic answer. Not totally done answer because it says solve the two sides. Check. I'm sorry. I lost track of my checking. Check, check. And then number 4, it says graph. Okay? Be less than or equal to 9. Positive. Closed circle going that way. X has to be greater than or equal to 1. This is an and situation. When it's an and situation, we need both where they overlap. They overlap here, all the way over to here. This is our solution. Our sandwich will look something like that. Okay? One more I want to get done with you real quick. Right here, this is greater. Get the absolute value by itself. Subtract 16. Absolute value of 4x is greater than 32. This is a greater. We're going to use the word or. Okay? 4x is greater than 32. 4x is less than negative 32. And there should be an or in there. So I'm going to sneak that in there quick. Keep solving. Divide by 4 all the way around. Lots of dividing by 4. Notice we're dividing by a positive, so everything's going to stay the same. And we have our or situation. Okay? Then we would graph that. And the graphs don't overlap here, and we don't need them to because that's how an or works. So you need to know how you write your two sentences. Is it an and? Is it an